Let's go ahead and get started. Hi, everyone. How is Project 4? Yeah, just okay? That was the worst academics you're a freshman, right? Ah, well, I'm not worried about that then, because you will have plenty of worse ones later on, I'm sure. What was so horrible about Project 4? I wrote most of the code for you. How many lines of code did you have to write to finish that project? What? There was not much code to write, but it is definitely a mental shift in how to write the code, right? Shifting from this imperative to object-oriented is a little bit weird, right? Because things fit together differently. They fit together differently. They do. Now, the question I had earlier was, do most of the people actually write an object-oriented code? And the answer is, sort of. I mean, people, when they write code, they are generally feel free to mix and match and do whatever they want. Some of the code that I've seen is what I would call C+. It's not quite C and it's not quite C++. It's somewhere in between. And people will do just mix and match stuff all the time. So they'll use objects where they feel like using objects and then not objects where they feel like not using objects. So I don't necessarily recommend that. All right, so you should have also have watched videos about what? Pointers. What is a pointer? Yes? Yeah, a pointer is a variable that stores in it not a value, but the address of something else. That's the technical answer. So the technical answer is pointer is a variable that stores the address of something else. But do you know what it really is? Pointers are power. Now, we talked about power on the first day of class, where you actually have power to do things with the computer. Pointers are your power over the computer. Pointers are where you get good stuff. And it's kind of annoying. How many of y'all programmed Java before? Does Java have pointers? No, it's a nerf language. You can't hurt yourself very easily with it. All right, never mind. That'll be a better joke when you're seniors. So pointers are power. Pointers are actually pretty awesome because you can just reach down with a pointer into the memory of the machine and tell it to do what you want to do. You can just reach in there and change values down inside the memory. Now, with great power becomes what? Great danger. Because when you start working with pointers, what you're going to find is sometimes you'll get something wrong, and you'll have a pointer to something, and you think it's a pointer to one thing, but it's actually the pointer to something else, and then you'll go change some memory values, and the memory value you changed isn't the thing you thought you were pointing at anymore, and then just weird stuff happens. Because the computer, as you can imagine, doesn't like it when you just start changing things randomly in its memory. That is bad. Okay, so that's what we're going to talk about today is pointers, and what we're going to talk about the rest of the semester is how to use pointers. And from my point of view, now we're getting into kind of the good stuff, the cool stuff of computer science. The other stuff is cool too, but this is where you really start getting into powerful, cool things. So, any questions about the videos before we start? How many of y'all watched them? I didn't check statistics today because I was running late. Good. All right. One other thing I wanted to mention, by the way, in this class I try to choose topics that are not just like completely boring examples. I try to choose things that have some real world value. Does anybody here besides me commute home and listen to NPR on the radio on the way home? No? Just me? Did you hear the story yesterday, the big story? So the big story yesterday was that the American, I believe it was the Heart Association, though don't quote me on this, came out with a new website that has, guess what? A heart attack risk calculator. That is the calculator that they are suggesting people use to determine whether they should take statins, like Lipitor and such, which are drugs that help prevent heart attacks. And there are complaints that the new calculator that they came out with is too pessimistic, and that using the data from this calculator, too many people will be put on these drugs that don't need to be put on there. So, there you have it. What you're working on actually has real world and policy tie-ins, even though what we're doing now is computer science. And the reason I bring this up is just because, remember, the theme of this class is computers are cool and they solve your problems, not the problems that people at Microsoft think that you probably have. Okay? So you can use it for anything, at least I believe so. All right, so the other good news is that we have extra Halloween candy, so I'm back to throwing candy around because I don't want to have to eat it. Yes, sir. I'm not going to do it right now, though. All right, so since we watched the video, we're going to start off with a worksheet. We're going to do one side, we'll talk about it, and we'll do the other side. The first side that we're going to do is a side that says pointer-related operations, okay? And this is just to take a look and go through all the different, like, things. Yes? Oh. All the different operators in the way that pointers work. So I tell you what, can you just pass that to your, that way? And pass those over. One for you. Pass those over. Pardon?
Thanks again for clearing it.
Oh yeah, no problem. I did that for like 4 other people. So. You're welcome. Thank you. All right, so the first one we're doing is the page titled Pointer-Related Operations. And this is just, I don't know, mix and match. So for each of the things labeled A through G above, I want you to look at the individual operations below and tell me in there which ones are which. Thank you, student. All right. So go through, there's 8 different things. Each of the numbered items might have, oh, I'm sorry about that. I walked right by you too. Each of the items might have more than one thing associated with it. So go ahead and we'll work out which is which. And you can feel free to talk to each other about it. I'm not, if you want to do that, I don't mind. Oh, man. I don't know. Why not both? Just for redundancy in case. Whichever you like, as long as you're, I mean, this is for you. I'm not going to grade it or anything. Y'all done? How many of y'all mostly done? Not done? Arm injuries? How many of you have just given up? For giving up? No. In fact, you probably owe me a Pop-Tart. Yeah, for quitting? There's no quitting. There's no quitting in computer science. What? Oh, bravo. Yes, except for that. Here, you deserve a candy for that. Except you deserve his Pop-Tart for that. Do you like Pop-Tarts? I don't know how we opened these before. All right, let's do one more minute, and then we'll just go over these, and we'll go to the next one. All right, let's go ahead and go over these. So, one of the weird things about pointers, and one of the things that makes them particularly confusing the first time you learn them, is that the symbols that we use for pointers are overloaded. And what does overloaded mean? More than one meaning. And so it gets confusing working with them because sometimes you just can't quite tell, like when you're new at this, what you're working with. So the idea of doing this first is that we can go over the symbols and we can kind of see them in different contexts so we understand just literally what it says so how we can think about it, okay? So this first one, int star x, which one's that? It is a declaration. How do you know it is a declaration? But we have stars elsewhere that isn't a declaration, right? Say again? I heard someone shout half of it out. It's between the type. So the rule is, if there's a type followed by a star, that is a declaration. That is a declaration. A type followed by a star is a declaration. We're going to see the stars elsewhere, but anytime you see a type then a star, it is a declaration. So this first one's just a pretty simple declaration. What's the next one? Oh, do you want candy, by the way? Sorry, too high. Okay. Get more candy today. You have to answer a question first. You answered one too? Okay. Oh, man. Okay, so what's this next one? Who wants to try this one? No one? Yeah. Uh-huh. Okay, so the star is one of two things. The star is either a dereference operator or a pointer declaration. Okay, how do you tell if this is a dereference or a declaration? No, this is confusing, right? This is why we're doing this. So this right here, what is Reynolds' subject? Is this a type? Does it followed by a star? This is a declaration. Here we just declared a pointer, but we didn't set it equal to anything. This is a declaration. And what we're setting it equal to is actually something that is dynamically allocated. So if you watch the videos, and I kind of alluded to this time, before, most of the variables that we've been talking about are things that have names, right? So if I say int x, what does this do? Declares an integer named x, and somewhere over here in memory, we have a box that's named x. And anytime we've talked about that box, we refer to this. But it also has an address, right? And it can just be some number. What's happening now is with these dynamic allocations, we are declaring variables that do not have names. All they have is addresses. And if we're declaring things that have addresses, we have to record that address somewhere so we can use it. Does that make sense? So what this is this is a declaration that that is set to the result of a dynamic allocation. And we're going to see this more and more as we go through this. This is something that is dynamically allocated. It doesn't have a name. So literally, if we want to draw a box for this, here's what's happening. We declare something, and I'm just going to use RS as an abbreviation. We declare Reynolds subject X that is a pointer, and that's literally means this box is going to be named X, and it is a Reynolds subject pointer, which means it has an address in it. What address does it have in it? Well, we call this new keyword, and the new keyword says, hey, you're creating a brand new one of these things that doesn't have a name, but it does have what? An address. So what the new keyword does is says, hey, here's the address of that thing you just created. So down here somewhere, we have this thing, which is a Reynolds subject. What's its name? It doesn't have one. What is its address? Whatever it is, this might be, like 0x7ff3 or something like that. And what happens is this address gets stored up here. And we are able to find this subject later by saying, oh, we have a pointer to it. Here's the address. If we go to that address, if we dereference that address, we can get the value that's in there. So, does that sort of make sense? Sir? It is not at all different. The only thing that's different here, this one we declare a variable, and we don't set it equal to anything. This one we declare a variable. This is a pointer to an int. This is a pointer to a Reynolds subject. But in this case, we are actually setting it equal to something. And the thing we're setting it equal to is this magic command, new, that says, hey, give me a new one of these. And it just does. It goes, okay, I created a new one. Yep. Yep. Nope. It's a pointer to a Reynolds subject. And a pointer is always just going to be address. Good question. Yes? Uh-huh. Yes. And it's stored something of type integer. So anytime we use new, anytime we use this magic new, something is going to spring into being. And the thing that's going to spring into being is whatever type we tell after it. Okay, when we say new int, new Reynolds subject, new point, new string, we can create something that just springs into being. The thing that springs into being doesn't have it doesn't have a what? What does it have? What does a pointer store? An address. All right, everybody with me so far? Yeah? Yes, so here's where you get into trouble. So the question was, yeah, I'm actually going to do this in code for you really fast, okay? So the question was, So the question is, what happens if we do something like this? What does this do? This should look familiar. We did this like 2 minutes ago. If you have a type and a star after it, what is that? A pointer declaration. And what's the name of that pointer declaration? So we have a variable named x. Does it store an int? It doesn't. It stores the address of an int. You don't know what. And later we're not going to care. What's going to happen is all this address stuff is going to happen in the background, and we're only going to be marginally aware that it's there. Mm-hmm. Yes. Yes, you've got it. What this does is this creates an empty box, and what this box can hold is the address to another box, and that other box has an integer in it. X is the name of the box that holds the address that points to the other box that has an integer in it. That other box doesn't have a name. So, quite literally what this does, here's our box. It's named X. It has an address in it. Whatever. This address is actually, and the reason they're called pointers is because when professors get up and talk about stuff, we just draw little arrows that point to another box. So literally what this did is we create a box named X. It's a pointer, so I'll put a star in front of it, and that means it points over here. This holds an address, this holds the actual value. Now the question we have now is what happens if you do x equals 5? Is that what your question was? Because that's what question I wanted to hear. Okay, so here we have our box, and we put 5 in here. What did we just do? We put 5 in the box where the pointer is. What did we just do? Oh, we didn't delete it. It didn't go to this other box. Here's what happened. What is this box right here? It's the address, and so this address now is pointing at what? Is it pointing at box number 5? What is in box number 5? Who knows? But I can tell you what, this is bad. Okay? When I told you that pointers were powerful because you could reach into memory and do things with them, and I told you that they were dangerous, this is where the danger comes in. If you accidentally confuse the value for the address, and you just start putting values in boxes that are supposed to be addresses, your pointers are now pointing off randomly into different places. No, it's not good. It's bad. It's very bad. Yes? Yeah, we could do it this way too if you wanted. That would be the same. They're the same thing. Yes. Yep. Okay. So when you're dealing with addresses and dealing with values, you have to be careful, which is one of the reasons I'm going through this exercise now of showing you the notation so that when you read it, you can think about it. And I can tell you the reason I think this is important is because I spent like days figuring this stuff out the first time I did it. And I can tell you when you're in trouble. Do you all want to know like a sign that you're in deep, deep trouble? And I'll tell you because I've been there myself on more than one occasion. It's when your code isn't doing what you think it should do and you just start putting stars and ampersands in random places hoping that it will work. Okay? If you find yourself when you get to the point where you're like, I wonder if it needs a star in front of it, and you just throw a star in there and like, that didn't work, let me put an ampersand over here. You just need to stop. You need to go like have a snack, watch, some really dumb reality show that involves people on an island or something like that, and then come back and like look at your code and figure out what's going on. Okay, because it is confusing. There's no doubt about it. So, what does this do? Int star x declares a pointer named x, and a pointer is a box that can contain what? And what does this do? It sets the address to 5. Okay, it sets the address to 5. And if you're ever setting the address to 5, you're doing something horribly wrong. Yep. Ah, yeah. All right. So the question is, what happens if we put the star in front of this? This works perfectly. No, it's not. Actually, this is bad. I shouldn't show you this. This is bad. That's not going to work either. So, but we're just going to pretend that that's bad. So, we'll see about dereferencing in a second. Does that help? So, you can't just do this. If you just do this, you'll have a problem. And you know what your problem is? The problem is that when you declare this, where is x pointing? What address is in x when you declare this? I don't know. So if you use the dereference operator to follow the pointer and set it when you get there, you've just set something randomly in the computer memory to a different value. You actually have to make sure your pointer is initialized and holding a value before you can do that. So we'll get to that in a second. Sir? Do you want me to go back to this thing? Okay, here's the deal. There will be times in computer science when we're working with data sets and data of uncertain sizes. What do we use right now when we have data that's going to be an uncertain number of items? We stick it in a vector, right? How do you think vectors work? You already know. How do vectors work? Vectors work using pointers. Behind the scenes, pretty much any vector, anything like that, is using pointers. So now, all semester long, I've been saying magic. Now I am turning you into very wimpy and impotent wizards. But, you know, I'm showing you some of the magic anyway that's going on behind here. All right? And what's going to happen is that we're going to use this new command when we need an additional thing, because we're like, you know, reading something in that we would store somewhere, and we just need a place to put it. Now, there's one flaw in my logic here that I'm sure some of you all know, but you haven't brought up yet. And we'll get to that in a second. Okay. Yeah? The box with the address does have a name, absolutely. Yes? It is, for the moment it is. And that's the flaw in my logic so far, and we will get to that, I promise you. I promise you. This is, I'm so excited for you to be learning this. And so excited to watch your suffering. I know that part, it's not true. Yeah. Uh-huh. Yep. New, okay, so we can break this up into two steps if we want. We could do this. That is also legitimate. What does this first step do? Reynolds subject star x. What does that do? That holds what? Absolutely. What value does this box have in it when we initialize it? We don't know. It could be anything. Okay? So, one of the dangers with pointers is if you start working with them without initializing them, that means you're just randomly doing stuff that's somewhere in computer memory. You're putting stuff into the wrong box, and you don't even know which box you're putting it in. You should always initialize them. So, one way to always initialize them, and we'll see this a little bit more, you can use null. And null means nothing. An alternative to null is 0. 0 is reserved. I mean, there's like, in theory, a box there, but in practice, it's reserved that you'll never actually put anything in that box. So that's how you initialize pointers. We'll get to that. It's kind of like a preview of coming attractions. Okay. So this says, go into memory. New means go into memory and find a place you can stick one of these things and tell me what the address is. So new means find a place in memory that's big enough to store a type. In this case, it's our Reynolds subject. And a Reynolds subject is a package containing a whole bunch of stuff, right? So it gets like a really big box for that. And then tell me what the address is. Because we're using the equal sign, this whole thing says, it goes into memory, it goes, oh, I'm looking for a Reynolds subject. I'll find a big enough box for that. I will take the address and I will, using the equal sign, stick it in X. And because X was a pointer to a Reynolds subject, now we're all happy. Okay. Everybody good so far? Yes? All right, great. What is this next thing? Did I throw you candy already? Okay. So you're brave enough to step up. Okay. So that's what these things do. I'm just going to erase this because we split it into two. Okay. So this last one, how y'all doing? Do you want to stretch, wiggle for a minute? You've been sitting down long enough? All right, jump up and down, scream. Who needs a piece of candy? Do you have a preference? All right. Who is going to step up to try this next one? Anyone? Anyone? Bueller? Int star next int open close parentheses. What is that? Yeah. All right. Is this a pointer declaration? All right, that was a good joke. What is it then? All right. This is tricky. It's really annoying that the terminology is this way. What do the open and close parentheses mean? A function. What does every function have? A name and a return type. So int star next int, this is a function. A function has to have a return type. What is the return type of this? An int star. This function is returning a pointer. So the rule I told you, which I now have to contravene, is that if you see a type in a star, it's a declaration. That is true unless the thing that comes after it is a function. So this is not a declaration. But a function return type. Do you see the difference? Here you go. Oh, sorry. Yes?
So it's a type followed by a star followed by a variable.
Yes. And this is this declaration. Oh, that's a good way of looking at it. It's okay. Declaration is type followed by star followed by variable. Pardon? A function, you can have a function that returns a pointer. So a function, you can run a function when the function's, yeah. How about this? How about it says, here is a whole bunch of Reynolds subjects, find the one that has the highest Reynolds score. And so it looks through it, and at the end it goes, oh, here is the address of the box that has the Reynolds subject that has the highest score. So you can return pointers as well, and the function can do some calculation that says, hey, look in this box over here, and you will find the answer you're looking for. Yep.
So is this one the in star next in? Is that an address operator?
This one right here, next int, there is no address operator in there. This is not an address operator. How many of y'all think this is confusing? How many of y'all this is helping? Please tell me this is helping. Okay, so this is a function type, and you can tell because it has a type, star, and function. And how do we know it's a function name? Yep. So this is a function. It returns a pointer to an integer. Everybody good with that one? Questions? Yeah. Do you want me to explain this again? Sorry, I don't quite understand your question. Go through the three. Oh, do you want me to read this to you like I would read it? Okay. Next int is a function, which we can tell because of the parentheses, that returns a pointer to an integer. Okay. Next int is a function that returns a pointer to an integer. So pointers can be a return value. All right. So here's a line of code. Y equals ampersand x. What's going on here? Sir? So what is ampersand? Ampersand is the address operator, and implicit in this is that y has to have a type. What type would y have to be for this to work? It would be a string pointer to whatever type x is. So it has to be, this implies that y is of type, and I'm just going to say x's type pointer. Because it has to be a pointer to the same type that x is. So ampersand just says, hey, here, get the address of this variable and tell me where it is located. Yep. Yes, exactly. Somewhere above this, for this line to work, there would have to be a line that said whatever type x is. If it was an int, it would be like int star y. Right? So it implies that y is declared as a pointer of whatever type x is. Yes? It is, because x is a box that has a name. And the ampersand says, hey, go look at this box and tell me what number, what address it's at. It is. All addresses are just hexadecimal numbers. Because we have to keep track of what it's pointing to. So if x was like a box that held a Reynolds subject, then we would have to do like Reynolds subject star y. If x held an int, we would have to do int star y. And I haven't really mentioned this, but the whole reason this is because C and C++ are what are called strongly typed languages, which means you have to keep track of what every type of the variable is as part of the program. There are languages that are weakly typed where you can just like not worry about saying what they are. Yes? Uh-huh. You're not sorry. You're confused. That's the difference. I'll unconfuse you. Yep. Nope. So I'm going to write a little bit of code underneath in comments. So it also implies this. No, not quite. So that implies this right here, y equals ampersand x, implies that somewhere we had a box named x that had a type. When I say that y has to be of x's type, that means it has to be an int and has a star, because this is declaring y as a box that can hold an address. And the ampersand operator is saying, hey, go to x, and don't look at the value, but just tell me where it is, where its address. Yes? So the question is, why do we use the star instead of just using... You could set y equal to an address. You absolutely could. You don't want to do that, though. The whole point of using the star is that in your code, when people look at it, they understand that it's an address, right? If we just, since you're absolutely right, since these addresses are just big numbers and int can hold a big number, we can just put addresses in there, but then we can't tell what it's supposed to be. So remember, a program is an algorithm that can be expressed and a computer can run it and people can read it. With all this star stuff, they've done a pretty bad job of making people able to read it, but it helps on that. Wow, this is taking longer than I expected. All right, so let's go into this one. What's this right here? Int star y equals ampersand x. This looked pretty familiar. We're doing the same thing, just in one line. We're declaring a pointer and setting it equal to the address. So this is the address operator. This is declaring a pointer. Okay. Now remember, when you talk about, like, when we're printing out these addresses in hexadecimal numbers, they're just big numbers. We're just printing them in hex because they're easier to look at that way instead of like decimal. But we can print them out as decimal numbers as well. All right, void calculate int star x, int ampersand y. What's this thing doing? Yeah. Uh-huh. Exactly. Function prototype with a pointer parameter and a reference parameter. Which is which? First one's a pointer, the second one is reference. Why do you think they use the ampersand for both the address of something and for a reference pointer? It's fun looking at everybody's eyes and watching them look away. He's like, yeah. That's exactly why. Because when we're using a reference parameter, we've been saying that magically when you change something, it reflects back to where it came from. The mechanism by which it's doing that is the reference parameter is just saying, hey, instead of working on the variable, work on the variable at this address. And that's the entire magic behind reference parameters. Is that instead of working on a copy of the parameter, you work on something at that address. Absolutely right. Would you like some candy? Okay. All right. Now we get into something slightly different. Int y equals star x. What's going on here? Yeah. No, because we have the star right here, and we have not yet talked about what it means to have the star right in front of a variable. What does that mean? Yeah. Yes, it is. And what does a dereference operator do? Exactly. So this star says, hey, go to the address that's in X, like X is an address, go there and tell me what value you find there. So, whereas before we've seen the star as declaring something as a pointer, this means follow that pointer. So what this really means is, it implies here, X is a pointer, And that someplace up above, we had something that looked like this. Int star x was declared. And in this case, the star operator means go to the address in x and work on the value there. So x has to be a pointer. We dereference the pointer, which means we actually go to the box. So if I can go back to my box, the thing that I've drawn before, what this implies is there's a box named x, and there's some address in there. And the dereference operator says, go to x, dereference it, which means follow it, and find what the value is in that other box, which might be some value like 9 or something. So the dereference says, give an address, go to the address, and tell me what is in there. Yep.
So, just to be clear, the star, when it's right in front of a variable,
Uh-huh.
the dereference
Operator.
operator,
Yep.
when there's nothing else in front of the variable. Or can
Yes. No, if there was an int or something else in front of that, that would be a declaration. Most of the time you see the dereference operator, it's going to have an equal sign in front of it. It may on occasion be inside parentheses for a function. Okay? That will change the, so yes, to use your terminology, x is a box. Box has an address in it. The address points to another box that can hold an integer. This means go to the box that address points at and changes something. It does, essentially, yeah. A reference parameter kind of works in this same thing. Yeah, so when you use a reference parameter, you're giving it an address and saying, hey, here's the address of the thing you're going to work with. So the function, when it changes something, actually goes to that address. All right, everybody good so far? Anybody want to take on this last one? This one's just, I would call it for fun, but the other word might be for sadistic cruelty, torture purposes. That's exactly what you're doing. This is what's called a double. You can have a double pointer. You can have a box that's an address that points to a box that's an address that points to a value. And this follows it through 2 different steps. This is what it's called. Oh, yeah. This is called, you're never going to see this again. I just put it on here. Well, you're never going to see it again in this class, or if the world comes to an end tomorrow. It's called dereferencing a double pointer. And essentially you have a box that has an address that points to another box that has an address that points to something. Okay. But you will occasionally see that, and what you need to know at that point is that you have a double pointer and you need to call for backup. Yeah.
Okay, so it has something like int star star I.
Uh-huh.
Would that be
Yes.
declaring a double pointer?
Yes, this implies, right here, this implies that somewhere that something like that was declared, a double pointer. Now, in the past, I've shown classes double pointer stuff, but we're not going to actually do any double pointers because they're evil. Yeah. There are problems where a double pointer is actually very handy that I cannot explain to you right now, but I will explain to you in a couple of days, okay? Once we've gotten through some other stuff. All right, so that took way longer than I thought, but now we have our basic terminology. Flip your sheet over and go ahead and do the exercise on the other side. Now that you know what the operators do, apply it to some code. You answered a question. I didn't mean to.
When you're outputting y,
Yep.
aren't you? So okay. So this is a pointer, right? That so it's that it creates. Okay, so if we're outputting that pointer, are we outputting the address of the address of x?
We're outputting the address of x, but not the address of the address of x. You're never going to do the address of the address of something that I can think of in like any normal thing.
But okay, so why can we say? Oh, are we? Wait, so I don't see how printing out y prints out the address of x.
What's the address of x?
I mean, this is the address of x.
And yeah,
And
I told you something to assume right there. What does that comment say?
right. But I thought this created a box that points to that.
Int star y creates a box that can point to something. This sets the address in the box to point at something. What is it pointing at?
Oh, okay. It's pointing at that address.
Uh huh.
I don't even know. I just made some
Is this the same thing as this one that we just talked about right here?
Yep. That's the same thing. Uh huh.
So
That's
this
it.
is it seeing out the address?
Yep.
Or
It's printing out the address of x, and I gave you a hint there of where x was stored so that you could know what x is. Your question? Sorry, yes or no? Okay. All right, one more minute. We'll go over this briefly. All right, here we go. Who wants to tell me what this program is going to print out? Some brave person. Go ahead, sir. Okay, so his prediction would be 10 OX7FFF, OX7FFF, 10, 10. How many of y'all think that's right? How many of you don't know? All right, well, we'll run it really fast. If I can remember where I put the file. I can't do plus plus. All right, the compiled well, pointer. I cannot type today. All right, so it outputted 10, 07 FFF and some other stuff I didn't expect you to remember. That thing again, 10 and 10. Okay, now the question is, why does it do that? Should we look at the code and step through it and see? All right, where do we start tracing code from? Yeah, I'm not going to. Yes. All right, int main. We start from int main. That was his candy for answering the question. No, it was yours. Did he break your computer? You can sue him. Okay. So int main. What does int x equals 10 do? Creates a variable named x of type int and stores a value of 10 in. Cout x, 10. No problem on that, right? We've seen that once or twice before. All right, cout ampersand of x. What does the ampersand do? Yeah. You don't. But how did I know that? Because you're impressed when it ran, I did that? Well, because I missed like the last 8 significant digits, and I just happen to know a little bit about where the program puts things, and also I tested it like last night when I wrote it. So nope. See, it's in different boxes. This one's D3, CB, E4, so it's not always putting it in the same box. Yeah. The answer is magic, but that magic is all done by pointers. Okay? There are pointers everywhere. Has anybody ever heard of a program called Excel? Anybody heard of something called Excel? Every single box in a cell is actually, when you say equals like A3 or something like that, is actually a pointer to another box in there. It's nothing but pointers. Excel is nothing but an exercise in lots of pointers. I'm telling you, hopefully you're beginning to see the power of this. When I said pointers are power, I was not kidding around. Pointers are behind everything. And when I said that I'm inducting you into this like first step of the magic, I'm really serious. Pointers are very powerful. Everything uses pointers. Okay? And yes, every time we run this program, it's putting X in a different spot when it runs the program. Sometimes it might end up in the same spot. I mean, if we... Yeah, probably. There's a lot more stuff that's going on behind the scenes for this that I'm not going to talk about today. I will talk it about to you when you are seniors in your operating system class. Or you might get it in hardware along the way. So this is, I'm telling you, everything we've been doing up until now is just skimming the surface lightly. Now we're starting to look down, and there are sharks and kraken and stuff down in there, okay? So, but now you're also armed with something more powerful. All right, so to get back to the code, int main, x equals 10, we print out 10, we look at the address of x, and we happen to know that it's going to start in the range of 7FFF, and there's a bunch of other stuff behind that, but we're not going to try and keep track of all that right now. So we print out that address. And we're good so far, right? All right. Now we int star y. What is that? A pointer or what? Declaration. We're declaring, and we know that because there's a type, a star, and a variable name. So we're declaring a variable that holds what? A what? You're close. The address of an integer. And now we're saying y equals ampersand of x. What type is x? So ampersand x makes it a address. Is that this type of thing we can put in y? So now it's in y. So now what we literally have, I don't even have to do very much. We declared x. It has a value of 10 in it. And now y is in here, and it has 0x7FFF. That happens to point over here to x. That's literally what we're doing. All right. So now when we output y, what are we outputting? The address, which is 0FF. And when we do this star y, what does star y mean? Dereference. Dereference means we know something has an address. Dereference means go to that address and work with the thing that is there. Got it? Good so far? Okay. Great. Now we're going to do this last thing. Cout angle star parenthesis ampersand parenthesis star y parenthesis parenthesis. What order do we do these operations in? Yeah. Inside out. Great. What does this star y mean? So y star goes down here to x. What does the ampersand mean? Tell me the address of the thing that's here. And so, well, it doesn't store this. It just changes it to be the address of this. And then what does the dereference mean? Go to the thing that's at that address. And in fact, if we want, we can keep adding stars and ampersands. Like the star kind of cancels out the ampersand, right? All right. This is kind of like, this is the very most basic overview of pointers I could possibly give you. All right? And we're going to do more with them throughout the semester. And if you stay in computer science, you will do more and more with pointers because they are amazingly powerful. And they let you do cool stuff. But first, there's one thing that I've been glossing over this whole time, and Tommy had it earlier. What was the thing that I've been glossing over about pointers? No! You'll have the rest of your career for that. There's one weird thing that we've been doing that I haven't shown you yet. And you alluded to it. Maybe you didn't even notice. The whole point of having a pointer is so that we can access elements that do not have a name. Right? We can access elements that do not have a name. Well, anytime we declare something with new, you have something that doesn't have a name. So if we want something that doesn't have a name, we can say something like y equals new int 12. And if we do this, if we see out angle star y, boy, I hope this works. This would work in Java. I hope it works in C++. Wait a sec. Did I save it in the right place? Oh, I saved it to the wrong place. Excuse me. 1 second. Okay. Now it should work. God, that was horrible. Yeah. So here, now we've added 12. And what we've done is we've added this. We say y is equal to a new int that has an initial value of 12, and output dereference y. Y holds the address of this integer. What's its name? What's its name? We don't know. It just doesn't have one. This integer does not have a name. It doesn't. No name at all. It's living, it's an integer, it's down in the box in the depths of the computer, remembering the number 12. If we want to go there and see what that value is, we have to say star y, because y remembers that address. Star y means go to the place where that integer that doesn't have a name is and tell me what the value is. So we're much better off now, right? Because now we're able to use things that have no names, right? And we will never have this problem where we have to name everything again. Yes or no? Why not? So, if we want to get the thing out of x, we just say x. If we want to get the thing out of here, we just say star y. Right? Have we helped? Why not? Because we still have to have a name of a variable that stores the address of where this other thing is, right? Like, what good is it doing us now to have these pointers if for every single pointer we have to have a box that has a name to be able to grab it? Have we helped anything? We have not helped anything. We have not helped anything if for every pointer we have a name. And for every object we create down there, we have to have like a named pointer pointing at it. Does that seem like a problem? I'm going to show you the magic. Yes. Do you have a question first? I'm happy to try and explain it another way. What if we have a lot of stuff stored in that box? Is that what you're saying? We could store a lot of things in the box. Like, for example, we could have a pointer to a Reynolds subject, and it would have all that Reynolds subject data in it. But for each Reynolds subject, we would still have to have a box that held the name that pointed to that. So we wouldn't be much better off, would we? Do you see what I'm saying? Yeah. So right now, for every pointer, there's a name. We have a name for the box that holds the pointer so that we can access the thing that it's pointing at. And that's not cool, because we haven't gotten around this problem of not having names. So let me show you what we're going to do. And this is where things get fun. Do we have a way that we can package different data types together into the same thing? An object. So an object can hold data of different types, can it? So let's say we have an object. Let's say that we're interested in storing a number of integers, just for ease of use. Okay? And what we want to have is we want to have just one thing. And this is going to be, x, and it's going to be a pointer. So right now, what we could have is we could have one integer, and this thing could be the address that pointed at this one integer. And we haven't done ourselves any good because we still have to have one named variable that points to the box. That's where we are now. Everybody see that? Well, how about this? How about instead of just having an int in this box, we have two things. We have an int and the pointer to another integer thing. Except we're not going to have these be integers because we want to package them together in a class. So we're going to call this, say, a node. So what we're going to have is we're going to have a node, and the node class is going to have two things, an integer and the pointer to another integer. Pardon? Yeah. And what's going to happen is we're going to have an address that points at one of these node things. Where are the other nodes? Well, this is a pointer, this is a pointer, this is going to point at the next node. And what's going to happen is we're going to take all of these nodes and hook them together based on the pointers that they have inside of them. We will have one named variable. This is going to be called the head. The head is like the top of the thing where you can keep track of it. It's going to have one pointer. We're going to have one thing with a name. This pointer is going to point to a box that has two things. The two things are an integer and the pointer to the next box. Each box will have space for storage, an integer, and a pointer to the next box. Yes? Uh-huh. We care about them. We care about them, but we don't really care what, we care that they're there, and we care that they're addresses, but we don't care what the value is. Well, the only thing that you, the only thing that you have the name of is the head. And it's like this. Say you're out fishing. Anybody ever been fishing on a boat? Do you go in the summer or in the winter? Well, you're crazy. Who goes in the summer? Are you in a boat when you're ice fishing? Then you're doing something wrong. Okay. You go out in the summer and it's hot and you're out on the lake and you're fishing and if you're like me, nothing happens. You're just really sitting there talking to your granddad for a while because that's what fishing is about. And you're hot. And so you go, I have all this Coke with me, but we forgot the ice chest. So what are we going to do? Well, we want to get it cold. We want to get it cold because warm Coke is foul, right? So, fortunately, the water's cold. Can we just throw the Coke in the water? Yeah, we could, but we'd never get it back again. It wouldn't do us any good, right? We could just throw it in there. So what we're going to do is we're going to take a piece of fishing line, because we're fishing and have it, and we're going to tie it to the Coke. We're going to tie one end of the fishing line to the Coke, and we're going to throw the other in the water. Okay? And then we have other bottles of Coke. So you know what we're going to do? We're going to tie each bottle of Coke to the next and just throw them in the water. So in the end, here's what it's going to look like. We're going to have our boat, and we're going to tie the line off, and then they're going to have like a bottle of Coke. I can't really draw a Coke bottle up here. And that's going to be tied to the next bottle of Coke, and that's going to be tied to the next bottle of Coke, and they're all going to be hanging off the side of the boat, getting nice and cool. And what do we do when we're thirsty? We grab a hold of the one thing that we have, that string that's tied to the boat, and we pull it up. And we get there and we go, oh, we have a bottle of Coke. And what's tied to that bottle of Coke? Another string. So we take that one Coke and we tie the string back to the boat, and we're fine because we've kept track of where everything is. A linked list in this analogy is going to be exactly the same thing. This head pointer is the piece of string that is tied to the boat. And everything else, in order to get at it, you're going to have to pull on that string and find the next one, then pull on the string and find the next one, then pull on the string and find the next one, all linked together like a great big daisy chain. Yes? So, you are jumping right ahead and stealing my thunder. The idea of this is that instead of, oh, I'm glad, everything here, instead of being an int in the next project, is going to be a Reynolds subject. And what we're going to add to the Reynolds subject class is a pointer to the next Reynolds subject. And instead of having a vector, we're going to have a pointer to the first Reynolds subject. And we want to look through the list. We're going to be pulling on the string and popping each one out and looking at it. Pulling on the string, popping it out. One box has the entire Reynolds subject, everything in there. And it also has like this pointer to the next one. Now, why are we using linked lists? Anybody know this? You heard of linked lists before. Why are we using them? Because two reasons. The first is that this is the very simplest thing that we can do to teach you how to do pointers and to teach you to do these operations. It is the very simplest thing we can do. And so we don't want to set you something insane and crush your will to live. We're going to give you something simple. And the second thing is that linked lists, which is what this is called, are incredibly common. They're actually useful for all sorts of things. Your computers that are running right there, every single computer on there keeps track of every program you're running on a linked list. You have a program that's essentially, here's all the information about the programs running, here's the linked list to the next program. And when it comes time to switch between programs or to quit, your computer is manipulating that linked list. So not only is this something that is a good example for pointers, it is actually completely real and completely useful and very common. All right. So I'm excited for you all. By next class, I'm going to put up some more videos. It's going to go give an overview of this. And next class, we will get into more of these operations towards a linked list. Oh, Project 5 will be posted by next class. Anybody want to guess what Project 5 is? Same project, except you are not allowed to use vectors.